Hello, this is the last part of exercise number 2. Just to let you know, I just noticed the data table doesn't have a spot for this, so just write it underneath the first part of the lab. So we are going just to see if things are trying to see if they have any magnetic shielding effect. In other words, can you shield this compass from the magnet? So you see the compass, there's a magnet right next to it. And what I've done is drawn the direction of north. So you can see that the thing is not pointing due north, it's pointing off of due north. So what we want to do is try different things to put it in between the compass and the magnet. I put the magnet close enough so that the compass will deviate from north. It's about, let me see, 10, 25 degrees or so. So it says 45 degrees, but it's okay. It's easy to see this way. So I'm going to put my hand in there. So watch the needle really, really carefully. We want to watch the needle. If the needle flickers or anything like that, then the thing is either magnetic or it shields it. So if I put my hand in there and all of a sudden the needle goes straight north again, that means my hand shields magnetic fields. And it turns out there's only a very few number of things that will shield anything from magnetic fields. I mean, plastic's not going to do it. Cardboard, paper's not going to do it. You can see the needle's not moving. But let's try something that we did in the previous step. Let's do a scissors. You see how it moved ever so slightly? Now the reason it moves isn't because it shields it, it's because it adds to the magnetic field. This scissors is made out of steel, so it's adding to the magnetic field. If I move it around, you can see that it goes in the other direction. So if I make the scissors go this way, it goes counterclockwise. If I put the scissors in this way, it makes it go clockwise. So, and again, that's because the scissors have been sitting around in my drawer for a long, long time, and it's been magnetized by the Earth's magnetic field. So it's weakly magnetic. So it is going to strengthen the magnetic field and weaken it depending on which direction it's in. Let me try my duct tape. Let's see. Nope, the needle does not move with the duct tape. Good old duct tape. Duct tape. And I'll put another iron bar in. So this is made out of steel. Notice that it flipped counterclockwise. Now what I'm going to do is flip the iron bar the other direction, and you will see what happens. So it depends on which direction I'm putting it. One direction it goes clockwise, the other direction counterclockwise. Again, this iron bar has been sitting in my lab. It's actually a little rusty by this point. And decades. Yeah, I move it around every once in a while, but it does get a slight magnetism, especially since I put them in my solenoids. You're going to see me use them later on, and it helps magnetize them even more. Okay, so that's it for exercise number 2. Let's start exercise number 3 right now.